All right. Hello, everyone. Welcome back to another episode of Adventures in Machine Learning. I'm one of your hosts, Michael Burke, and I'm joined by
Ben Wilson.
And today we have a very special guest named Fernando. He almost introduced himself there, but I will do the intro. So he studied computer science at UNAM, and that's NAUM for the non-Spanish speakers out there. And then after graduating, he worked at Connexus, which is a company that focuses on connecting disparate data systems through API calls. And he was an ML engineer there. And then currently he works at Hitch. He started off as an ML engineer and is now head of data science, which is super exciting.
Hey folks, this is Charles Max Wood from Top End Devs, and lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv. And I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So, Fernando, do you mind elaborating a bit or introducing yourself?
Yeah, of course. First of all, thank you. Thank you so much for this invitation. And I will talk a little about my background. And well, yes, as you mentioned, I graduated in computer science field, and I did a master's in the field of artificial intelligence. I conduct my career towards natural language processing. So by my side and for industry, I've been working in problems related to natural language processing and a little bit of knowledge graph. And for Connexus, the first company you mentioned, I work mostly with knowledge graphs and a little bit of traditional machine learning, let's say it. And then I moved to Hitch, that is a company based on Mexico City. And what we do here is essentially trying to connect candidates to positions, and we try to automate the process by using video interviews. And so the core that we do here is applying machine learning models to video interviews. And this is the part that I'm doing here at Hitch. And there's too much to do with video interviews, trying to apply different approaches to solve different problems. It is not an easy thing to do, but it is a really, 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 really exciting area field. I'm learning a lot. Yeah. And besides that, I think I really like to learn a lot by myself. You know, I really like to write blogs, Medium blogs, trying to teach how to do some things, some sort of tutorials. And I actually like to practice, as I mentioned before we started, and practice coding data structures, because I think if you want to be a top-class engineer, you really need to know data structures, algorithms. And I think it's a little bit hard, in my opinion, but I think we can get it. So, well, this is me. Yeah.
Cool. And what do you do to practice?
What do you mean exactly?
Like you said, you like to practice data algorithms and structures. What do? Do you just like go on a website and like type up an algorithm, or what exactly does that process look like?
Okay, yeah. For example, with LeetCode, I think it's a very famous platform for practicing algorithms. I really like to practice on contests. You know, weekends there are contests where you have 5 or 3 problems for solving, and I try to solve them. There are some pretty good competitors over there. But yeah, besides that, I really like to write blogs. I think I wrote a pair of blogs about how to approach on specific algorithms, like the famous two-sum, dynamic programming. And this is what I refer to when I'm saying that I really like to practice about data structures, algorithms, and this sort of stuff. Yeah.
So you're the second person I've talked to this week who comes from like an ML data science background, who was talking about the benefits of focusing on software development skills in order to level up like the ability to push production code out. And particularly when you're doing data science work or ML work at a company where you have a budget. So how do you feel that, where would you rank the importance of solid software engineering fundamentals in working towards production grade ML?
Yeah, okay. I think I realized that, yes, maybe, I don't know if this year, but maybe this in these past 2 years, that it is extremely important, highly important to be a really good software engineer to have the skills for the knowledge about how software engineering is in real world. Because, for example, when you are working or you are forming or conducting your career in the area of data science, you're more focused on maths, statistics. But at least here at college, you're not aware that at some point you will need to be able to put your model in production, or to use some cloud services, or how does REST API works. And I think it is extremely important to have the base. Well, yeah, to the base of the software engineer skills. And yeah, but you need to find your way because, for example, here in my case, all my career was based on maths, then on statistics, then on natural language processing, and I had to do some code, but I have not a specific formation like software engineer. I need to learn that on the way, on the fly. So, but yeah, this is because I realized that it is extremely important, and I realized that because, for example, here at Hitch, this is a startup and we're a small team, so you need to cover different stages in the process. You need to be the data engineer, you need to design the system, the machine learning system, but you need to put that system into production, and you need to do different things. And if you're like, hey, I'm just a machine learning engineer or the data scientist, I don't know how this is going to be used in production. I just have a model with good metric, like precision, recall, whatever the metric is. And I don't know what's next. I think you are, it is sort of good because, this is what you're doing, being data scientist. But again, if you want to be a top class data scientist or machine learning engineer, you need to learn you need to know data engineering, software engineering, data structures, algorithms, and you need to push yourself to know how software behaves in real world because it's really exciting. And I consider myself that I'm learning it. I know some things. I can do some things, of course. But I think that, I'm not in the level I wanted to do, but I think I will get it one day. So, because I've learned some top class machine learning engineers that are, for example, what you mentioned you did at the beginning of this conversation. For me, it's like, okay. I think that is really hard. So yeah. Well, just summarizing, I think having the basics of software engineering and learning constantly how software behaves in real life, in production, in industry, is a must. We need to learn that, so we need to be aware of that. Yeah.
Quick question on that. So it sounded like you were talking about three things. First was data engineering. Second was how production software works. And then the third was like data structures and low-level concepts. I'm on board for the first two, but can you sell me on the third for why we need data structures and low-level concepts? I mean, I think a lot of ML engineers are not going to be coding in anything below Python. So why do they need to know or be able to implement a hash map from scratch?
Okay. For example, I will give you a basic example. Let's say you build an API, and you are receiving a list, and you need to find some item over there, or you need to process this list. How do you do that? Are you gonna, I don't know, build 2 for loops? How you are gonna do that, or are you gonna build or design a better data structure in order to make more efficient the process you need to do? And the impact of this is that maybe the latency of your API is going to be better, instead of if you are just trying to put some, like, solving just the problem, and that's it. And yeah, you are receiving the response, and the API is cool, but the latency is not. Maybe it could be better. Maybe at some point it will breaks. I don't know. I think this is why I think it is important to be aware about their structures. Obviously, I am aware of that, because there are discussions about, hey, I never have to rotate a decision or a binary tree. I never have to do that. So yeah, maybe not, but being aware that there are some structures that you can use for some specific problems makes the difference. This is why I think it is really important. Yeah.
I couldn't agree more. I mean, I'm kind of on your skeptical side there at first, Michael, with like, does a data scientist, do they need to know how to implement bubble sort from memory, or do they need to be able to process B trees and find search items? Probably not. ML engineers should be definitely familiar with that. Maybe not recall it from memory, but they should have done it at some point. And exactly as you said, Fernando, that one key phrase that you said know which one to use for what time. The only way you're going to know when to use a for loop versus a list comprehension in Python versus set operations. Each of those has drastic performance differences in them. For effectively, you could do the same thing with those, but knowing which one to use at what time and just being aware of the existence of those is incredibly important. I've seen it a lot of times with data scientists where they're going through and iterating through collections, maybe nested collections. They're in Python. They have like a list of dictionaries, and within the dictionaries, it's in some sort of JSON format of dictionaries within dictionaries. And they just write a for loop, like iterating through all of the items. And then within the items, if there's a dictionary, then iterate through those items. And they wonder why it takes so long. Or maybe they're running writing some test code on sample data. They're like, yeah, this executes in like a second. Or they don't even notice how long it takes. And then they scale it up to their full data set. And they're like, oh, the platform's broken, or this library's broken. And really what it is they wrote something that's, 2 to the n in complexity because of the way that they did that. And if they just refactor it with collection operations, it's all of a sudden ON in complexity. So I think it's important too.
Yeah.
And one more pitch is, which I've seen a lot more, at least so far at Databricks and in prior roles, being able to write functional style programming concepts, and it's really easy to do in Python, but having those functional style operators that can be easily distributed across multiple cores is, I would argue, even more valuable. I could be wrong, but it seems like being able to distribute across a bunch of cores is one of the fundamental issues with big data. So for loops are often really, really hard to distribute. Just another pitch there for low-level concepts.
Yeah, because at the same time, again, you need to be aware of how to write optimal code, how to apply the optimal structure, the optimal strategy for traversing a list, or maybe instead of using a list or a set or whatever the thing is. But at the same time, you need to distribute your data, because here in Hitch, we don't have a million of data. So maybe we're not facing that problem yet, but we will do maybe soon. I am aware of that. When you are receiving a million of requests or million of whatever the thing is, you need to be aware how to handle, how to distribute that load to different cores, to different parts of memory. So I think that's totally another stage that is absolutely really, really important. And I'm a machine learning engineer. I don't know. I realize I need to cover different stages, because nowadays the machine learning engineer is thought like the guy who can train AI models, but he is able to put those models into production, and he's able to handle all data from a company. At least this is my experience. I don't know what do you think, guys, but in my experience, is like what in industry or the companies I've been involved with, and they see the machine learning engineer like the guy who can handle all data from the company, train the model, put more into production, optimize model, choose the better cloud infrastructure, on-premise infrastructure for handling all data. So yeah, I think it is a little bit blur about what the machine learning engineer can do, but it is what it is. So we need to be able to be adapted. I think there will be a case that maybe you in your way or me or wherever the guy is will find a company that really knows what they want to achieve by hiring a machine learning engineer. So, hey, guy, I need you to train this model, use this data, and put this into an API. So, I think there are not, in my case, I haven't found companies that really knows what they want to the machine learning do. But yeah, there may be some.
Yeah, I'd say it's a factor of company size and maturity in the ML space. I mean, I've interacted with many hundreds of companies worldwide in my tenure at Databricks, and have seen teams that are, the ML team is a team of 1 or 2. And when you're at a small startup like that and there's just a couple of people, maybe it's a team of 5, it's the ones that work really well like that are teams that maintain a diverse talent. So you might have somebody that's, pure math or physics based data scientist. They understand the mathematical implications of, creating this solution to this problem. And then you'll have somebody that's operations focused. Like they understand the business, the problem domain. They can, usually that person is dual hatted. They'll do the BI for projects. They'll also do some data engineering, but they're learning data science stuff. And then you'll have somebody who is data science / ML engineer focused in the term that we were kind of talking about with, okay, you know a lot more software than you know about just pure data science stuff. So that's sort of the person that would look at a project and say, all right, I know how to convert this script into testable code, and I know how to set up CI. I know how to use the tools at my company's disposal to figure out how to get testing working correctly and making sure that we're not releasing something broken. And then you might have somebody else who's pure software engineer who's doing deployments, monitoring, logging, making sure that they're reviewing every PR and making sure that the code is maintainable and extensible. So in those small startups, I see a lot of times everybody has the same job title, but they all do different things because they're all specialized in something different. If it's a team of 2 people, they're triple hatting it. That's why startups usually hire the best of the best if they need it, if they're really serious about it. But at massive companies, they'll have specialization where there may be different job titles, or I don't think that's kind of ironed out. And I've always been kind of skeptical of job titles anyway. I think they're kind of stupid. Just call everybody a human, whatever. But you're going to have a team or a group of people that are specialized in, like, hey, these are the data science type people. They build models, they experiment, they test things out, they use tools that other people on our team build and maintain. But then for production deployment, it's a whole different, set of skills. And what you described in that process of like, hey, you need to understand how software works and how computers work, and what Michael was saying with distributed computing, that's the scalability of batch offline processes. It's really important that people on the team have, like, at least a handful of people need to have that specialty or grow into it.
Completely agree. So changing topics a little bit, I was wondering, Fernando, if you could elaborate a bit on some of the challenges that you guys at Hitch are working on in the ML space. Like, what are you trying to forecast? How are you forecasting it? And what problems do you run into?
Yeah, okay. Well, there are different, there are many projects here. All of these projects are achieved to make some, provide some results in very short time. But being realistic, there is one core project, that the first one I mentioned at the beginning, that is about, we have video interviews, and we are trying to score these video interviews. But the key thing here is that we are trying to emulate how a psychologist used to evaluate a person. For example, if we are interviewing here or in some interview, some person with some specific background, some specific the specifics of psychology, it is supposed that they are able to score how the communication of this guy is, how is the guy shown to solve problems, whatever the skill they are evaluating is. But the key thing here is that we're trying to model that part by using machine learning. Now we have built a strategy for that. So we have a team of psychologists that are labeling data. So we need the label. So we have a set of psychologists that are continuously labeling dozens of videos that we receive, and then we are implementing some strategies based on NLP. So in conversations with psychologist teams, we realized that we can't model this problem by using only what the candidate or the person says. So for example, if I responds in some way, the psychology says that, hey, if the guy responds in this way, this shows that this guy has a high score in communication. He seems to be really good at solving problems. So these kind of things. So we have videos, we have a set of labels, and we're implementing natural language processing models with this data. And but the challenge is what kind of models do we use? We want to use just state of the art models just because these are state of the art, or how are we going to do that? So what I just suggest here was to start from the basics. So we are using just Bayesian approach for solving this problem. So what is the probability of being good or not good or bad of some specific for some specific variable that we're measuring, based on that the candidate says this phrase, this word, this two words, this whatever the domain is. So this is what we are doing. The challenge is, again, we are trying to model something that I think is complicated, but at the end, well, at the same time, I think it's, in my opinion, the next step of the recruitment process. This automation through videos and how to extract, how to score some psychological features from videos by using AI. So I think this is the challenge we're facing. We're working on it. We have some models with some sort of good results, but the key is we need more data. We need more videos. We have, not too much videos, tens of thousands of videos, and are not enough for generalization. And another thing is that we are only focused on the domain of Mexico. So people in Mexico used to respond and speak in some specific way. But when we interview another person from Latin America, from, I don't know, Argentina, they used to use another kind of word. So this makes the problem more complex. So our model is very limited to a tiny small sample. Because we are only modeling right now how Mexicans based on Mexico City used to respond, giving us some sort of question.
That's super interesting when you think about that. If there's actually, since you're analyzing video, you're processing the images as well, right? Of saying like, hey, how does this person look when they're saying these words? You would think that there would be regional differences as well, even within a country where everybody's speaking a unified dialect, or maybe there's different accents of like, hey, in the Yucatan, people speak maybe a little bit slower than people in Mexico City. And then up near Baja California, you have, a different way of speaking, but people are using different slang terms. But when people speak differently, if you shut the sound off, you don't even listen to what they're saying, but just looking at how they make their facial features while they're talking. How does their head move? Do they use their hands? All of those are latent factors that could influence what you're trying to analyze. So that's such an interesting problem to me that you're trying to solve. And when you say the solution to that, to generalize it, is to get more data, which is, a widely accepted answer.
Hi, this is Charles Max Wood from Top End Devs. And lately I've been coaching some people on starting some podcasts and in some cases, just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
I have a question about labeling. When you send a video to an expert who's going to apply labels to this video and saying, yes, this person is being honest or being helpful or being generous or kind or whatever the labels may be, do you ever do group validation in the labels? Like take a sample video and send it to all the psychologists and see what the label agreement rate is?
Yeah. Actually, we do that. And this is part of the how complex the problem is. Because when doing that, we realize that we would expect that in some universe, all the psychologists would score with the same, let's say, with the stars, with 3 stars at one candidate. Taking a look at the same video, but this is not the case. There are some. If we plot the distribution, there are some spread scores through the mean, so it is not perfect. So this is sort of like bias or noise to our model, because in the perfect scenario, we would expect again that all the experts used to score with the same label, but this is like sort of like a loop with the idea that Hitch has. Like, yeah, we're aware that this is everything based on subjectivity. So different experts can score in different forms based on their moods, how they feel, whatever. So we are trying to standardize all of this by using a pool of experts. So I think this is our first step. But the most optimal, I don't think so, but I think is one step towards the optimal solution, where the optimal solution, I think, is 10 steps more in front of us. Yeah.
Yeah, I mean, I feel your pain. I worked on a project a number of years ago that had the intention that we started it with was that it was going to be objective. And it was in the fashion industry. We were trying to like apply a label to the look of an outfit for women. And the idiot that I am about fashion, I was like, oh, this is objective. Like there's categories here. You know, designers say that this is this thing. And then 6 months into the project, and it was a part-time project that I was working on, I was like, wow, this is so subjective. I pulled, I was getting labeling done by a group of people at the company who were experts in the fashion industry and just blindly accepting the labels they were giving me. And the model was it wasn't consistent. Every time I'd retrain it, even with locked in hyperparameters and, the same number of iterations and same number of epochs. And I was like, man, is TensorFlow like this finicky? Is it like, I thought this was a good package. And playing around with the structure of the deep learning algorithm. And then, somebody that sat next to me, used to be a data engineer. He's like, have you checked the labels? And I'm like, no, the experts did it. And he's like, yeah, but did you send like a picture to all of the experts? Like see if all 30 people agree? And I was like, that's a good idea. So I took 100 images and sent them to everybody. And we had less than 50% agreement on all 100. So I was like, all right, this is subjective. So then you have to constrain your space and say, hey, we have to have a rubric and get consistency among the experts. And then all of a sudden our data got so much better and the model got a lot better. But yeah, it's subjectivity in expert analysis and the bias that comes with that is a very challenging thing to solve. Yeah. And that's what I was talking about. That person in the group that has like that operational know-how, that sometimes that's another hat you have to wear as an ML engineer. It's like, hey, you have to talk to the business and you're not writing the algorithm part. You're not writing code for this. You're thinking through a problem and working with people to solve it. So that's cool that you're already making all those leaps and bounds in analyzing this.
Yeah. Since we are aware of that, we're working to teaching the experts hey, based on this rule, you need to score this guy in this way. And we have those strategies and we are making progress on that. But the results are not perfect as we would expect. So as we would expect that the result, I don't know if it's perfect. Well, I would expect perfect results. Yeah, but subjectivity is like we are humans. We are subject. Well, we used to apply subjectivity to our jobs that we do to whatever we want to evaluate. So yeah.
Two questions / ideas. The first is, if there's not consensus between labelers, theoretically you could use some other factor like job success. So if they get hired and the hirer is happy with them, maybe you could use that as a label. It's definitely there's a lot less frequency of that label and it's latent. But have you guys thought about doing that?
Yeah, totally. The key thing here is that we have not much clients so let's say we start with 1,000 candidates and we end up with 10 positions. So we cannot like have too much feedback from clients. But what is true is that we apply different assessments. So one is the first or the core one is the one based on video interview, but candidates used to play some video games, or well, these are not video games, are like games in order to measure how they are able to solve some specific problems, and we measure some things based on that. There are some other open questions, like based on theory of the position they are applying to. If it is an economic position, they are asked about this question. So we try to implement different assessment and we collect all the information. But the key thing here is that we are trying to consolidate everything into the video interview. So we are trying to build something that can evaluate end to end by only using video interview. This is the core thing here. But again, as I said at the beginning, we're in the first step from, 10, 100 steps. Yeah.
Got it. Yeah, that makes sense. And then the second idea is, it seems like everything here is so, just thinking about the hiring process, in my experience, it is so biased. It is so messed up. It is so just seeing who gets hired, who doesn't, why they get hired. It's just mind blowing. So using the current status and the current societal evaluation of people, I think that would perpetuate a lot of bias. But that aside, have you guys ever thought about creating a more deterministic system where instead of using, I'm assuming you guys are doing, you are doing all supervised learning, you do an unsupervised feature extraction approach and then take those extracted features, run it through a deterministic, weighted equation, and then have your candidate score based on that. So an example would be, if you have okay, you're smiling. Now I'll just stop. What are you guys doing?
No, actually, I was smiling because you explained what we are doing. So based on these assessments, we got data, we got results. So we try to find how these results from one specific candidate are grouped together. So based on this, we try to determine how good, how not good, or how very good is this candidate. So this is how we we consolidate all results. This is how we do that. So it's sort of like you said. At the beginning, in order to get data at the beginning, because this is the second iteration of HITS, by optimizing how or changing how we are scoring candidates. In the first iteration, we have some specific heuristics for consolidating all the information, because we had no data, zero data we had. So yeah, we defining some heuristics, like if it is more than 0.5, this is a good, and if it is less than 0.5, this is not good, something like that. And then we consolidate everything. But in 1 year, we collect enough data in order to apply this now supervised learning. And then we extract how our first iteration of candidates behaves. So based on that, we determine how to build the second phase of this project. And now we're applying on supervised learning for extracting this, let's say, thresholds. Essentially we use the previous data for getting the thresholds.
Do you do any work on preparing for potential outliers by using actors to hire somebody and say, hey, I want you to act completely crazy during this interview. say a bunch of inappropriate things, gesture wildly, or flip the table or whatever. Do you do that to say like, hey, here's a condition that we obviously know is checking all the boxes for the human we don't want to recommend that anybody hires. And then also an example of maybe somebody that is an ideal candidate, but somebody you've already told what the best answers are to, and explain to them like, hey, act like you're, the best employee in the world, and like hire a professional actor to do that. Do you do stuff like that? And then also the second part of that, do you make sure that you are not having biases based on physical appearance of people?
Yeah, for the first question, no, we haven't do that. We haven't thought about it. What we measure is, for example, by using unsupervised learning, we realize that in some specific assessment, there is based on games. Some people used to just click, and that's it. And some of them are really good. The results are good because they just click on random and results were good. But we realized about it by finding the odd layers, so based on time. So we used to measure the time that they take to solve that assessment, and we found those as odd layers. So we classify those as odd layers. And yeah, this is like the most approximate situation related to what you mentioned. But like an actor, like behaving in a crazy way, no, we haven't thought about it, which is a really good idea, I think. Yeah, I realize it's a really good idea to consider. And what was the second one with the second question? Sorry.
I mean, if you're evaluating videos of humans,
oh yeah,
at a range of saying, okay, this is an undesirable candidate versus this is a really desirable candidate, across that spectrum of what you're trying to classify. If you're looking at the physical appearance of people or their mannerisms or something, you could introduce bias into a system if you don't have enough samples of either really bad behavior or really good behavior. And that limited amount, if people kind of look similar to one another or one gender dominates the other, most models are going to struggle with classifying accurately. And like, well, all the crazy people were, from this that we happened to randomly get that came in. They were all from this one town that's 30 miles outside of Mexico City, where people kind of look very similar, and they were all guys that came in. And then for your best candidates, they all just happen to be women between the ages of 25 and 35 from Mexico City that all kind of look similar. So anytime even a bad candidate who looks like that might overly associate like, oh, it's a woman in this age range, we're going to say that she's good, even if she's terrible.
Yeah.
If that was a bias that you were thinking about.
That's a really good comment. So we are not doing it. What we do here, for example, based on the appearance of some people, is video interviews are evaluated for our experts. So they follow this heuristic in order to score. And it is, we assume that they are not judging based on appearance or whatever the appearance of the person is. This is the most approximate situation that I can tell you that is related to what you mentioned. This is the most approximate things. But we are not like finding this relation, as you mentioned, like if there is a woman or there's a man, or if there they seem to be in some range of age or whatever. So we're not doing it yet, which is a really good idea. Yeah.
I mean, back to my previous story about fashion industry stuff, we were trying to run predictions on sales based on the cover shoot images of models, and we had bias in the model selection. I don't know if like the photographer just didn't really like this one model, but it seemed like they always set her up with the ugliest outfits. So when another photographer came in to shoot the models on certain days, regardless of what she was wearing, like sometimes this other photographer would put her in the thing that everybody thought was going to sell like crazy. And the model would always just be like, nope, this is going to bomb. Like, we shouldn't order a ton of this because nobody's going to buy it. And then the results, they bought it anyway. They're like, whatever. And we get the sales results a couple of days, like a week later or so. Like, the model said this is going to sell, was not going to sell more than, 500 articles of this thing. We sold out in 24 hours. What's going on? And then we did some analysis of the model and like, whoa, the model hates this lady. And it was because of that bias, that unconscious bias that was happening because one photographer thought that this model shouldn't be wearing, the newest, hottest thing whenever he was shooting. And then the other photographer didn't care, just randomly selected models. So it was just the shape of her. Like the model learned her face and learned that everything this person wears doesn't sell, which is incorrect.
Yeah, totally. We are aware of that. Well, I am aware of that. And we haven't thought in a strategy in order to not avoid it, because I think it's going to be really complex to avoid those kind of bias. But just to keep in mind that will happen and how we're going to act on that. Because, for example, just to give another example out of the box, when I was just playing around with some state-of-the-art models, NLP transformer-based models, I use one model in order to just test. I'm playing with this model. I just wrote a sentence like, "I am Fernando. I am from US." So the model used to had to complete the sentence. So the completed sentences, I think it was about like, "I am Fernando. I am from US, and I am happy with my family. And I used to go to college or whatever." So something really cool, positive. And then I just changed the country. I am Fernando. I'm from Mexico, and I had to leave my country because my parents are poor or whatever the model. I don't remember exactly what the model says, but it was like, oh my God, okay, I got it. So this is like an example of some state-of-the-art models, training models that we as engineers sometimes used to take for tuning and deploying to other place, these models. But we need to take care about it. We need to think about strategies about how to act on that, how to reduce, mitigate this sort of bias. For example, here we're aware of that. We're working again the strategy with these experts. We are making progress. Experts are not scoring perfect. We are aware of that, but we're working on it. I think in general, in terms of AI or machine learning, this is going to be a latent problem. I don't know if at some point this is going to be completely eradicated, but maybe, I don't know, we used to take action on that. And researchers, people are working on it, but I think it will take some time to eradicate or reduce that behavior.
Yeah, your story reminded me of the first NLP deep learning project that I tried. I was naive enough to listen to somebody and then read a couple of blogs, and I was like, oh, I have access to a Twitter feed. I could just use that to bootstrap this thing and it'll learn English pretty well. 2 days later, testing that thing out, I realized what a monster I had created. And this tool was completely racist and it was simulating the worst of humanity. And I was very eager to delete it. Yeah, I mean, depending on what you're using for your training data, it can expose the worst of humanity, particularly if you're using like unfiltered, unvalidated data, just raw from the internet. You can get some pretty terrible stuff in there. Your example is terrible enough that you mentioned, but that would have been one of the more positive things that came out of mine that I accidentally created. Just horrific stuff. And I agree with you about it's a long-term task when we're talking about anything where we're applying human bias and subjectivity to, and we train a model on that. And it's amazing to me how if you do that in a business and you train on the data within the walls of that business and then show it to people, the people that were the generators of that data, unknowingly, they didn't know that they were generating that data. They look at the output result of the model and they say, that model's messed up. It's so wrong. Why would it predict this? And then you show them the training data. You're the one that was the training data. You did this 2 years ago. This is you. It learned your behavior. And it starts to, be an epiphany to people. Like, wow, I guess AI isn't the problem. I'm the problem. So fix yourself. I think it's going to be a long journey. And that's one of the things that I'm most anticipating about an AI revolution in the world, is that it'll start exposing the horrific ways that we treat one another, or the horrific things that we do as humans, and start eliminating bias. At least that's my hope.
Here's a pitch. Most of these models use an unweighted training set. So I think as humans, we weight different types of interactions differently. Like if someone in the street yells at me because like they're crazy or I cut them off, whatever, I usually weight that a little bit less than if someone who I care about says something. That's one component. And then another component is that people saying bad things or like mean things is weighted differently in my brain than people saying nice things. And I think that because we're just using averaging, like we're optimizing an accuracy score that has no weights to it, it would make sense that it would take the volume over like an unweighted volume as the like core metric instead of putting some sort of like morals on it or putting judgment on it. And I think that's one really core component of the human brain that we still haven't gotten down, that we just sort of have to insert a weight vector into how we should care about good things versus bad things, nice things versus mean things. And obviously that's a lifetime's worth of work, but because models just optimize accuracy, it sort of makes sense that it would look at volume instead of treating things differently based on the content.
That's a really good point.
Yeah.
Sounds like we need to create an algorithm, man.
Yeah, Fernando, you in?
Build a model that does this.
Yeah,
I mean, I'm sure somebody has built that. I mean, like weighted optimizations. I don't know how computationally complex that would be, but it sounds really awesome.
Yeah, because I feel like the human brain has incredible computational power, but it does have a lot of structure around it. And that's what evolution has provided over time. Not just computation power, but that structure. Like we're inclined to, as a baby, want comfort or this or that. And models are just compute, and we expect them to learn those structures that it's taken like millions of years of evolution to develop. So
yeah, I mean, our brains and our consciousness is exceptionally good at ignoring data. We have to ignore, or else we would never be able to concentrate on anything. I mean, imagine the raw information that's coming into your eyes right now. You're looking at a screen of the other two people on this call, and if you were just to focus your eyes in the center of the screen, think of how much information is enclosed in that. And we can't focus on all of that. It would drive us insane, right? We wouldn't be able to process anything. It's too much data. But AI, it can't do that. I mean, it's through optimization, it's trying to figure out what is the most important thing to fit to, but it's still going to attempt to fit to everything that you're giving it. So I think that's to follow on to your point, Michael, that's the other thing that we're very good at. It's a necessity for us to be able to exist with all of the sensory data that we can collect, like every noise that's going on around us, the feel of everything in the room that you're in or wherever you are. If you're paying attention to every square inch of wind brushing against the hairs on your skin, that would be just too much data to process, right? So we have to filter and ignore certain things. I think that would be something that if there was an approach in an algorithmic way that we could set a setting and say, we're trying to do this thing with this set of data that should be focusing on these aspects. And if it can weight those in some way and learn from the data set itself, like, oh, this is really positive or this is really negative. I need to de-weight this and increase the weight here. Because that's the kind of our own subjectivity. That's what we do when we're paying attention to like, oh, based on my historical memory and my experiences, what is important and what is not important.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Yeah. I was thinking on that. I was like in a trip about thinking, how our brain does that. Because if we need to first know how we do that if we want to modulate it. I think that's my opinion. If we are not aware about how we do whatever the thing is, it will be complex to modulate it. But I think that in general, I hope in some years, in long term or short term, no, I think in short term, I hope so. AI can't be better on this because we are now in like baby steps of AI. So it is a fancy word. It is a hype. AI everywhere. AI. So AI-based companies. But the thing is that the real thing is that, well, it will take too many years in order to say like, okay, this really is AI. So
Yeah.
This is just something that I wanted to mention.
Yeah, I mean, I still think we're not. People are always saying, "Oh, we're 10 years off from the AI revolution." I'm like, no, we're 500 years off from that, in my opinion. Our brains have had how many millions of years to evolve into what they are right now. AI can't even do what a pigeon's brain can do, processing sight and hearing and sensation and hunger and desire. And there's so much going on there. So general intelligence, I think, is way far off. But one thing that I wanted to say while you were saying, like, oh, I was thinking about how do our brains do that? If any listeners or you want to have a fun little task, make sure you're in a safe space, but try to where you're not on like a concrete floor or outside on asphalt or on a hardwood floor, but like carpet. Walk across the room very slowly and think about every muscle in your leg, in both legs, as you're trying to walk across the room. See if you can do it 5 times in a row, where you're not thinking about looking at the edge of the room and being like, okay, I need to walk to here. Think about how you walk, of all the muscles that are in your legs and in your torso and in your pelvis. Which muscles are you activating in order to get your knee to bend and then your foot to bend up, and then move, basically thrust your hip forward in order to get your leg to move forward. If you think and concentrate on that for, about 100 steps, most people end up falling over or stumbling. So that's something that I've always explained to people about, like the complexity of how AI works and the fact that it's not processing all the information because we're not giving it all the information that we get. We have parts of our brain that are processing all of that data, but it's not in our consciousness. We're never really aware of it. But if you switch your consciousness to focus on something that normally is autonomous, your consciousness can't handle it. And I've always said that ML and AI is more like our consciousness, processing limited amounts of data in order to make a generalized decision on something. But people think of it as though it's like, hey, I can feed it all the data and it's going to learn what I want it to learn. And it's like our own brains don't work that way. So it's not going to work. But it's a fun exercise. Give it a shot. And hopefully, if you do stumble and fall, you have something soft to fall on. But.
Yeah. Actually, I was thinking very quickly about, okay, that is really, really extremely complex. So how do you extract that behavior in math and then in AI? I don't know. This really complex, really crazy.
Yeah, we don't even think about it.
No.
Think about speech, about human speech, about where your thoughts come, the next sentence that's going to come out of your mouth. Where does that come from? So our brains are far more complex than any AI that is ever going to be built in the next probably 500 years. And I challenge anybody who disagrees with me on that one.
Yeah, before everyone's brain explodes, I think, bring us back. We're almost at time, so we should probably wrap up. But those are all really insightful points. Like general AI I agree. I think it's really far off because it relies on so much inherent structure that needs to be created. Like you can't throw a neural net at life and it'll just know everything. You need, like Ben said, a filtering mechanism to know where to focus the attention. There's a bunch of other underlying unconscious and maybe even subconscious components that are very ingrained into how humans work and how just animals and organisms work. And if we don't have those structures in place, it's a lot to assume that our neural net will create that structure on its own. Like we've had tons of years of evolution. If you think about the complexity of the number of atoms on Earth, and then just like through years and years and years of those atoms bumping into each other, we've ended up with humans. Well, I mean, that's way more computational complexity than any computer can ever do until we get into maybe quantum computing or something. But yeah, so I'll do a quick recap of what we chatted about, minus the general AI talk. So for a practical piece of advice, if you're an ML engineer, it's probably a good idea to learn some core software engineering skills. Some concepts are how to productionize software. Data structures and low-level concepts are pretty useful as well. The main purpose of those is knowing when to use what type of algorithm, and then as well as data engineering and then distributed computation fundamentals. And then Fernando at Hitch, I just wanted to put this spin on it. So Hitch is working on using video interviews to score candidates. And whenever we're thinking about building models, you can use a really simple model and do a bunch of feature engineering at one extreme. or you can do almost no feature engineering and use a really complex model. Often you have to do some middle ground, but Fernando and his team are working on a really, really tough problem. So they do have to add structure and use really complex models. So they can't just like throw a CNN at an image and expect it to classify. They have to put a bunch of structure around what these incredibly cutting edge state-of-the-art models are doing and hope it works. And it's a really, really cool frontier. And it sounds like you're doing some really good work. So, yeah. So Ben, Fernando, did I miss anything on the recap?
I don't think so.
No,
cool.
You got it.
Sweet. So Fernando, how can people get in touch if they want to reach out or follow you?
Oh, yeah. You can reach out my LinkedIn, LinkedIn/in/Fernando. I think it's Fernando Lopez. And our Medium, I think it's better Medium at Ferneutron on Medium. And or my GitHub, GitHub/Fernando LPZ.
Awesome. Cool. Anything else from you, Ben?
No, it was an absolute pleasure. Great discussion. And you brought up some really important things that I think practitioners should think about, particularly when they're trying to tackle the Mount Everest of problems, which is, in my opinion, one of the hardest things that you can solve with ML is human behavior. And best of luck to you and your team. It seems like you're making some awesome progress on this type of stuff. And I hope it grows. I hope to eventually see it as a tool that we can use for hiring and recruiting here in the US and say like, hey, let's just run the video feed through here and see, does this person seem trustworthy? Are they going to steal money? Or, stuff like that. But yeah, it's an absolute pleasure and had a blast talking with you.
Yeah. I just want to mention, thanks again for the invitation, Michael, Ben. Nice, really nice talk. It was a pleasure. And thank you.
Of course. Well, until next time, it's been Michael Burke.
And Ben Wilson.
And we'll see you guys next time. Bye.
Later.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.